Hello my friends, welcome to Antidote Electronic channel. This is Uncle Misha. In this video we will try to continue working on the repair of, or at least analysis of the issue, I don't need this, of this main board from MZ-NE410E. And also we will check if this optical pickup is actually operational. All right, so you're gonna be doing two things. Okay, so how do we analyze this thing? So what already done some work. So I try to take a look and measure the ESR of all possible capacitors just to understand if there is any obvious problems with the capacitors. I couldn't find any. I couldn't find a short as well in some of the power rails. Again, I didn't do like very educated work. I just try to measure everything and I measure some power rail, but now I have to take a service manual and actually go through it more like precisely, like find the right spot, for example, to check power rails, because obviously I measure all electrolytic capacitors and try to measure if there is no short across one of those ceramic capacitors. It seems to be it's all right. So that's sort of, yeah, I won't say troubling, but not promising, because clearly we have an issue that the board doesn't start, but we don't know why. There is also the problem, as I mentioned earlier, without really looking into it too much. Where's my pokey thing? So in this area over here there is a corrosion, and I saw it somewhere else, like I think in this area as well, a little bit of corrosion. I'm not sure why there, because all capacitors, the only capacitor which show kind of weird ESR is this guy. So I'm not sure about it, but yeah, it will be obviously hard to desolder. I'm not sure why would it be corrosion here and corrosion here, because capacitor seems to be all right around this area. So I do not understand. Maybe some kind of garbage end up here, and with some kind of moisture was causing the corrosion. I'll try to clean this up with alcohol a little bit more precisely and double check the condition of those traces. Now, if it's gonna be in any help. Okay, so I will do it right now. Again, missing the rework microscope is a big deal right now. Okay, I clean up as much corrosion as I could. Let me try to put it back in here and see if we got any results, because also I need it probably back in anyways, because I would like to understand what's happening while you powering up, so measure some voltages. Like, it's not gonna work just like that. Well, there is a way to actually let it work just like that, but there is a whole bunch of teeny tiny connectors right here and right here, like a jumper pad. So you have to like solder over them, and you have to know which one of them does what. For example, some of them will affect those switches, right? Because if you don't turn on or press on these switches in a certain way, this thing would think that it's either open or there is no disk in there or yada yada. So you have to do that. So there is a special solder pads here which have to be shorted. So, and this also, I think, to activate the test mode. Some others probably for something else. I don't know all of them, but I know, for example, this to activate test mode, and I think some of here to kind of ignore the switches. But yeah, you have to, that could be specific to particular model, so have to kind of know that. All right, so let's try to put the laser back on and essentially to attach it. I will do it off camera, of course. Okay, so I have to install also one screw back on because the board was popping up all the time. So let's test the voltage of this battery, because I mean, I have to make sure. Yes, should be good. By the way, this hold switch could be a problem too. So if it's shorted or something happened to it, or it's corroded inside, so make sure it's working as well properly. Yeah, no signs of life. Okay, we have to use a power supply instead of the battery, just to see. Make sure to turn off your 25 volts to 1.5 volt. Yeah, that's very important. So this is our positive, this is our negative, and we can try, and let me first double check if the voltage is correct. So current limit is, well, 1.6 amp, but I believe I need that. So 1.4 volt it says here. All right, so we can connect it. So when I connect this, nothing happening, so it doesn't really. I'm gonna show you video from my cell phone. So this is how it looked like. Now when I press, where is that button? Okay, that's wrong. See what's happening? When I press, it jumps and it drops down. It jumps. So essentially, I do believe this guy. So look at this. Let's try again. Press, it jumps. Press, it jumps. Probably this power supply is not so fast. Probably current is actually jumps higher, but more or less within the range of like, I don't know, 50-60 milliamps, probably something to this extent. So this look like to me that there is, so this kind of jumping tells me that potentially there is a some kind of power issue. So for example, let's take something plasticky. So this guy, I'll disconnect it. So this guy is power management IC. So all power from the battery, well, in this case only from the battery, goes to this power management IC. And this gentleman is responsible to feeding power through everything. Yeah, so if this guy having issues, you probably have a problem. So for example, there is an issue with the with rail, with any power rail which actually comes out of it when you try to power this guy up and there is some kind of short or something like that, or abnormal load, not necessarily short, just too high of a load. This guy starts, senses the abnormal load, shuts down. This is, I believe, what's happening. Or this guy is bust. It's another possibility. So I'm not sure how we're gonna proceed here. So my idea would be, there's a whole bunch of little teeny tiny test points. I'm gonna just measure them and to understand what voltages are. So yeah, let me kind of think about my process, because that's like a gazillion of test points. How do I proceed with that? But this is the only way I can actually kind of try to figure out what's happening. I'll be back. Okay, after thinking for quite a bit, I decided to do the following approach. So I printed out some schematics, written out also some diagrams, which actually I indicated the voltages on each pins of this power management IC. Also, I printed out the blown up section of power management IC with all voltages on every pin and test points. Also, I printed out the diagram, or it's like a schematic diagram or logical diagram of how of the blocks inside this power management IC, just to understand, you know, what's happening. For example, like how this reg 01, reg 01, for example, works. So reg E1, it comes in, there is some kind of regulator and some kind of regulated voltage comes out, for example. Just this gives me an understanding what's inside, and looks like this is super complex power management IC. Also, I printed out the blown out view of the PCB. This is to locate those little teeny tiny test points. So I've done all this. Now, also I made a little table. So these are the important test points I indicated in here. Okay. So here, essentially, because this diagram also shows the directions of supply voltages for, this is the voltage part of the big IC or system IC or DSP, and in test points corresponding to those voltages, and obviously they are in direction of them is indicated right here. Essentially, this is all to supply either this system IC or some other parts of the how do you call it, the main board, part of the main board. So essentially made a table. So this is the supposed to be voltages. These are the voltages in standby, and this I measured some voltages when I press that button. So here's some interesting thing. So looks like this guy is powered by 1.5 volt when we are in standby. This is because these buttons are being scanned or listened to through GPIOs of this guy in order to wake it up, and not just buttons, right? All the switches, for example, if you open and close, this is going to be picked up by this guy and it will start reading and doing business. So that's why some of the pins, power pins, have 1.5 volts, essentially a battery voltage. So your battery will be 1.4 volts, going to be 1.4. It's unregulated battery voltage. It goes straight right here. Look, this little battery thingy, and it goes supplies straight. So this voltage is used by this power management IC to actually generate all those other voltages, because it has a whole bunch of inductors and, like as you see right here, and a whole bunch of other electronics in order to actually provide those specific voltages. And boy, we have a lot. We have 2.4, we have, so forget about this. We have 2.4, 2.1, 2.3, 1.5, 6.1, 1.3. Yeah, this is like no joke. Issue, what I see here, this is what I measured during the power on. It's a wake up cycle. So 2.4, instead of 2.4, we have 236. That's completely fine. Issues here, okay, instead of 2.1, we have 2.4, which is weird, and instead of 2.3, we have 2. So this is already quite suspicious. Okay, there is another interesting funny story. Instead of 1.3, we have 1.6 or 1.56. Yeah, so I tried then start tracing rails. So I was kind of thinking maybe there is some kind of bad diode or bad capacitor or bad something. So for example, I traced this 2.1 volt rail all the way. Some components I couldn't locate, they probably on the other side. This could happen. So I was tracing it like this, but when I completely disassemble it to access the other side, I'm not sure how it's going to work then. Anyways, and that seems to be all the same 2.36 volt. So I'm not sure why it actually generates 236 instead of 2.1. Oh, then I tried to trace this 2.3 volt. Why instead of 2.3 I have 2.04, or actually 2 volt. And again, I traced everything. So for example, for this, I didn't list it here. So for that voltage, this diode, this capacitor, and the other and stuff around it is involved. Okay, and all of them seems to be good. So then I decided to go the different route. So I decided, okay, maybe there is an issue with supply. Okay, so this 2.1 voltage, for example, it probably generated by VO2. So sorry, 2.3, right? It's supposed to be 2.3 volt, and probably L2. Probably these guys are bad. So what I end up figuring out, that voltage supplied here is correct. The voltage which comes out of here is wrong. Then I start tracing this guy, because look, by logic, they probably kind of, you know, there is some kind of signal switch coming in here, pulse width modulated driver, and yada yada. Everything seems to be okay, but this voltage is not okay. So at this point, I decided that either this guy, power management IC, is Gonski, and nothing I can do about it. So yeah, or there is something I do not understand, which could be completely possible. So I probably exhausted all my how you call it, possible scenario of how to figure out what's going on with this guy. I did all I can. I still cannot understand why here instead of 2.3 I have 2.22 volt right here. So yeah, I checked all capacitors along this way and they are all fine. Nothing shorted. Yeah. And I don't even understand why we have 1.5 instead of 1.3 and 2.4 instead of 2.1. Same kind of confusing story. I had few ideas. For example, I also detached this guy. I thought maybe there is some kind of short in the motors. No. The only last idea I have is actually to detach optical pickup and try to power it up, because I think this 2. If I'm not mistaken, some of this voltage actually goes all the way to the optical pickup. Which one of them? I think 2. Reg 01. Reg 01, yes. I think this guy goes all the way to here. Or VCO2. Yeah, 2.3. So this one is 2.3 here, this guy. So this guy goes all the way to optical pickup, and it is 2 volts instead of 2.3. So this, what I'm gonna do right now with you, gonna take this apart, I disconnect optical pickup and try to power this guy up. Let's see what's gonna happen. This is the last thing I do. Okay, if this does nothing, pretty much, I think there's gonna be game over for this mini disc player. Okay, we have moment of truth. Okay, I have disconnected the optical pickup. Here is the little, it's sticking out. Also, I disconnected the driver, just in case, because who knows, maybe if something happens, it starts moving around, it can rip this wire off because it sticks out on the other side of the board. Okay, let's see what we have. Oh, nothing at all. Huh. Okay. Looks like nothing happening at all. Isn't it like smart? No, it does. Okay. Yeah, it jumps. Okay, let me check that voltage. That specific voltage, which was 2 volts instead of 2.3. Let's do some negative here. And was it test point 905? Where's the? Let me find this 905 test point. Don't remember it by heart. 905 V out. It's so super tiny. My hands are shaking. Guess I'm worried, not worried, but anxious. Okay, I need to do max, because voltage is so transient, so I need like it's really, I don't want to touch anything. Okay, let's try again. 2 volt, as you see. Yep, doesn't go any further, so it's nothing to do with optical pickup. That was test point 1929, supposed to be 2.4 volt. It's 2 point, like, whoa, that's a bit of a change, actually, I must say. And 2.1, test point 909. I think if memory serves me correctly, 909 is right here, beside this teeny tiny resistor. Yeah, it's supposed to be like nothing changed. So instead of 2.1, it's like, see, what is this? No, something is wrong here. Okay, well, that's probably it for this guy. Yeah, I'm not sure what you can do. Guys, so if you have any idea what can I do about it, any kind of further, I don't know, investigation I can do, yeah. The only thing what I have left in my mind is to actually take this board out and try to figure out if this optical pickup is actually operational, but that's going to be in separate video. So for this video, we have failed to repair MZ-NE410 mini disc player. So this particular guy board is shot. We don't know what's going on with the display. We don't know what's going on with the optical mechanism, but so far this player is irreparable and in state like this. Well, at least we learned a lot. Honestly, I think that was kind of failed video. I mean, failed repair. Good video, failed repair. But we learned a lot. We learned that how the power management IC works. We learned the complexity of power management inside these mini disc players. Like, look how many different voltages it has. Yeah, and we sort of learned how to trace it to the point, you know, to understand where stuff goes. Yeah. Well, guys, if you want to learn more about repairs, please subscribe to my channel, especially some vintage electronic, because I try to restore some stuff, fix it, and bring it back to the former glory. Please like, subscribe, comment, hit the bell button to hear more about my videos, and stay safe. Ciao, see you next time.